Okay, so here we are, lesson 18. I'm a little bit late with these videos. I'm sorry about that. I don't know why. Anyway, let's start with the homework answers to lesson 17, which is these are they. So I'll put them up. You know the drill about stop and start. I won't bother talking it through again. Okay, so those were the homework answers. Now, we don't want to do the pregame stretch answers quite yet. Here, you can do the pregame stretch, which you can, of course, download off Moodle, or you can look right here, and we'll do stop and start. So here's the questions. You can just stop your screen, do it on separate paper. You know the drill. Now, a little bit of catching up. On the last set of videos, we didn't quite get to questions like number 19. The table in number 19 is not a function. The reason is because 3 has 2 different images. We'll talk about that a lot during the lesson today, so this won't be the only time you hear it. The bottom line is, if something is a function, every element of the domain has to have one and only one image. You cannot have 2 images of the same number. So 0.5 is good, 1.7 is good, 2.9 is good, 3.11 is good, but you can't also do 3.13. So if you took the last line off, or if you took the line above the last line off, it would be a function. But because because 3 has 2 images, it's not a function. Now, how does that manifest itself in a vertical line test? Well, the bottom line is that if you have 2 values for a given x value, then you will have 2 points with the x value, and that means if you draw a vertical line, you're going to hit twice. Whereas if you only have one value, one output or y value for an input or x value, when you draw the vertical line, you'll hit once. So the vertical line test states that if you draw a vertical line test anywhere you want through the graph, if you touch one and only one time, it's a function. If you touch 2 or more times, it's not a function. So on the left, the graph is a function. On the right, it is not. Take a look at 20. One of them is a function, one of them is not. Take a look, see what you think. Okay, so number 20 is not a function because it fails the vertical line test. It does touch only once here, and that's good, but everywhere else it fails. It's not like the whole graph has to touch twice. It's any single place in which it touches twice. And the one on the right is a function because no matter where you go, you'll only touch the graph once. Okay, so that's the pregame stretch. Now let's go over the answers to the pregame stretch. Here they are. You know the drill, stop and start. And that's the last set because after that we do the function thing that we already went over. So now we get on to today's lesson, which is right here. And we will go to slideshow and play from start. Fair at best image. I think that you're seeing the whole slide here, so I'm not going to swap displays. Okay, so today's topic, the new stuff for today will be radical equations. Today is the only day we spend on radical equations. Homework review, we already went over. Pregame stretch, we already went over. So now we're up to recent work recap, and we're not going to work as much with factoring anymore. If you still have factoring issues, please set up some office hours. We'll go over it together. But I feel after all the time we put in that we should be pretty comfortable with factoring. Okay? But when you have a lead coefficient other than 1 or factoring completely, I still want to drill some of that. So Let's go with numbers 8 and 10. Go ahead. Okay, so for number 8, I really wanted to come across this question because it teaches you the importance of knowing the calculator techniques here. Look, I got to tell you, I don't walk around with this off the top of my head for factoring purposes either. These are some pretty big numbers, and there is no greatest common factor, so we go to plan B, multiply both sides, multiply the last term by the leading coefficient, which is 12, and that creates x squared minus x minus 420. And very few people will walk around with the factors of 420 off the top of their head. So this is a great one to go to the calculator for. Under y1, put negative 420 divided by x. For y2, do the same exact thing, divided by x. Parentheses around it, of course. The negative 420 divided by x, I mean. You will get x minus 21 times x plus 20. But we're using plan B here. I had changed the question and multiplying by 12, so I have to balance that out by dividing by 12. Now, I can reduce each of these fractions because on the fraction on the left, the 3 goes into both, and on the right, a 4. So, what you see here is 21 twelfths reduces to 7 fourths, 20 twelfths reduces to 5 thirds. So, this is 4x minus 7 on the left and 3x plus 5 on the right. Let's check it, distribute back, and show you that this really does work. 4x times 3x is 12x squared. So far, so good. 4x times 5 is 20x. Negative 7 times 3x is negative 21x. That does add up to negative x. That's looking good. And negative 7 times 5 is negative 35. So this is correct. Not an easy question at all to factor. And if you can get that one, you're in great shape. You have really a very thorough understanding. That's about as hard as it gets in this course. Number 10, I'm looking for the greatest common factor, and I find it. It's a 5. So I don't have to do that first step. I factor out the 5. I'm left with n squared minus 4n plus 3. And then I factor n squared minus 4n plus 3, and I get n minus 3 times n minus 1. Now, you will have one like this on your quiz today. And I'm warning you now that this can be a very big hassle for students. Inevitably, some students forget to include the 5 in the answer. You can't leave out the 5, you can't leave out the n minus 3, and you cannot leave out the n minus 1. All 3 parts have to be included in this, okay? All right. Now, difference of 2 perfect squares. We've done a number of days of this. I think the concept should be down pat. This is just a little bit of reps and drill for you. Go ahead. Okay, so remember, in the middle there's really a plus 0x. And that allows us to that means that the numbers on the back end have to be opposite signs and the same number, and that only works because of the square root of 16 is 4. And then you're going to have plus 4 and minus 4, which adds up to those 0 x's. And of course, the square root of x squared is just x and x. Next one, x plus 2, x minus 2. The next one's a little trickier in that it's going to be 3x plus 7 and 3x minus 7 because the square root of 9x squared is 3x. And the last one, 2x plus 3, 2x minus 3 because the square root of 4x squared is 2x and the square root of 9 is 3. Just don't forget, you always have opposite signs in the middle. It's a plus and a minus. Now, factor completely means there's some code in that. It's saying, look, you have to have 2 steps or more, but at least 2 steps involved in this factoring. So go ahead. Okay. Now, let's take a look at what the answers are. First one, they share a 3 in common, so I factor out that 3. Leaves me with x squared minus 3x minus 10, and then I factor that to x minus 5 times x plus 2. Remember, all 3 parts have to be included in the answer. The next one, they share an x in common, and fortunately, that leaves a difference of 2 perfect squares. So it's x, x minus 12, and x plus 12. Okay? And then, remember, all 3 parts have to be there. Next one, this is x to the fourth, but this is a difference of two perfect squares. So I get 4x squared plus 9 times 4x squared minus 9. Okay? 4x squared minus 9 can be further factored into 2x plus 3 and 2x minus 3 because it itself is a difference of two perfect squares. There is no sum of two perfect squares. So 4x squared plus 9, that's it, done, over, because there's no way you could get 0 x's in the middle. Last but not least, 81x to the fourth minus 16 would be 9x squared plus 4 times 9x squared minus 4. For some reason, I had a bit of a brain cramp here. This should be 9x squared plus 4 still. I didn't do anything to that. And then 3x plus 2, 3x minus 2. So that is a factoring completely question. All right, so here's your quadratic formula. Oh, let's go back a little bit. That's what you have to solve. Go ahead. Okay, so we know here in this particular problem that the A is going to be 1, the B is 2, and the C is negative 9. I really should have written that out. But substituting the values into the formula, I get x equals the negative of B, which is negative 2, plus or minus B squared, which is 2 squared, minus 4 times 1, which is A, times C, which is negative 9. And just crunching numbers now. That's negative 2 plus or minus the square root of 4 and 36, which makes 40 over 2. Square root of 40 is about 6.3. So negative 2 plus 6.3 is 4.3. Negative 2 minus 6.3 is negative 8.3. 4.3 over 2 is 2.15. Negative 4.3 over 2 is negative 4.15. So there are the two values. If they ask for radical form, there's your radical form. Radical form has a radical square root in it. All right. We did one like this the other day. Remember to set it over 1 and cross multiply. Go ahead. Okay, so when I cross multiply, I'm going to get x times x plus 1 equals 6. Distributing, x squared plus x is 6. Subtract 6 from both sides. X squared plus x minus 6 is 0. Factor it. X plus 3 times x minus 2 is 0. Maybe it's the guy on the left that equals 0. Maybe it's the guy on the right. Subtracting 3x is negative 3. And adding 2x is 2. If you check them, they will work. Okay. Next one, rectangular patio measures 6 by 8 meters. It's to be increased in size to an area measuring 105 square meters. Now remember, we did one like this the other day. This is our second crack at it here. You'll probably see one like this on the pre-test too. If both the width and the length are to be increased by the same amount, what is the number of meters to the nearest tenth that the dimensions will need to be increased? Just want to help you a little bit. Show you the diagram here. You're increasing by the same amount, which we don't know what that is, but we'll call it x. They are both the same. And that makes this length on the bottom x plus 8, and the length on the top x plus 6. And if you multiply length times width, you get area. So keep on going. Okay. Now, length times width is area. So x plus 8 times x plus 6 in either order is 105. I do the math here. X squared plus 14, x plus 48 is 105. Subtracting 48, and I get x squared plus 14x minus 57 equals 0. And you know what? I don't even bother to try to factor that. Why? Because it says to the nearest tenth, and that's also math slang or math code for Pythagorean quadratic formula. Because the quadratic formula is the only thing that spits out answers to the nearest tenth. So now keep going with the quadratic formula. Okay, so putting it into the quadratic formula, negative 14 plus or minus 14 squared minus 4 times 1 times negative 57 over 2 times 1. It's just crunching numbers here, and you have a calculator, so it's not that hard. That gives me the square root of 424 under the radical, which works out to about 20.6. Now, there is a little bit of an advantage to this question. The x represents a length. We cannot have a negative length. So you can forget about doing the negative 14 minus 20.6 part of the plus or minus. Just do the negative 14 plus 20.6, which gives me 6.6 over 2, which is 3.3. And then what will the dimensions be to the nearest tenth that the dimensions will be increased? That is 3.3. Okay. Try these two guys. Okay. Now, for the first one, which one is a function? This is kind of difficult for you because we haven't gotten too involved in this, but if you look at choices 1, 2, and 3 and ask what do they share in common that choice number 4 does not have, it's that in each of choices 1, 2, and 3, the y is squared, which means that when you square root to solve for the y, you're going to get, like in the quadratic formula, a plus and the minus, which means that you're going to get two different answers for every x that you put in there. Whereas for number 4, when you do this guy, this is a regular parabola, which is like a smiley face or a frowny face. In either event, a vertical line only touches once. The x squared plus y squareds are circles, so the vertical line will touch twice. Okay? All right. So now, on the next one, f of x is equal to x squared plus 4, and g of x is the square root of 1 minus x. So what's the value of f of g of negative 3? So the first thing I have to do is figure out what's g of negative 3. And I'm going to go do that now. G of negative 3, I plug in a negative 3 into the g function. So the input is x, so I put a negative 3 in place of the input x, and I get 1 minus negative 3, which is the square root of 4, which is 2. So now I have to find f of the 2 that g of negative 3 equals. So that's 2 squared plus 4, which is 4 plus 4, which is 8. So the final answer is choice 3 or 8. Now you can use the table to try to do this. Go ahead. Okay. Final thoughts? Okay, so I have to do, remember, whenever you do these, when you use the composition function notation with this, if you will, zero, it's kind of like a zero, but it's not a zero. It's just a floating ball or floating circle there. You go from right to left. In other words, the first thing you do is f of 3, and then you go do g of that result. So what is f of 3? Well, here's the f of x function. Here's where the input, the x is 3. The output was 5. So now I know that f of 3 is 5. So now you're asking what's g of 5? So the g function is on the right, and here's where the input of the g function is 5. Okay, and now the output of that is 8. So g of f of 3 is 8. Choice 3. Okay, go ahead, try this one, a little evaluate guy here. Okay, so you've had your time to do stop and start. I'm just going to plug in a 3 every place I see an x, because it says f of 3, which means 3 is the input, and it takes the place of the x. So I get 3 to the negative 3 minus 3 to the 0 plus 2 to the 3. Well, 3 to the negative 3 is 1 over 3 to the 3, which is 27. So it's 1 over 27 minus 1 plus 2 to the third is 8. Now, you could just type this into your calculator. Just type in 3 to the negative 3 power minus 3 to the 0 plus 2 to the 3. Or you could go into y equals and type in x to the negative x minus x to the 0 plus 2 to the x. And then go look in your table for the answer. The problem with doing it that way is you're going to get a decimal, and then you're going to have to see, well, when you get your decimal, it would say 7 point, and there's only one choice that begins with a 7, so you would know it's choice 2. Okay, so we don't have to worry about that. Okay, the accompanying graph shows the elevation of a certain region in New York State as a hiker travels along a trail. What's the domain of the function? Go ahead. Okay. Now, here's the thing. It wants to know what is the domain. Which letter is domain, X or Y? X. So I can toss out choices 2 and 4. Now, the X on the graph is right here, and that goes from 0 to 12. So choice 3 is the correct choice. Okay. Let's do a little inverse function work here. Go ahead. Okay, so switch the x and y, solve for y. That means get y by itself. So we subtract the 35, divide by 7, and I get y equals x over 7 minus 5. Same idea in the second one. Switch the x and y, solve for y. X equals 3y squared minus 7. Add 7 to both sides. Divide by 3. The square root of y squared, because that's all that's left, is equal to the square root of x plus 7 over 3. And then the square root of y squared is just y. So it is y equals square root of x plus 7 over 3. Next up, a little review of the work we did the other day. Try finding those 4 values. Okay, so f of 1, 13, right? The 1 turns into a 13. F of 2, 33. F of 3, 53. And f of 7 down there at the bottom, 133. Try these guys. Go ahead. Okay, so what's the image of 4? 4 becomes 73. What's the image of 5? 93. What's the preimage of 93? So look at how this works. The image of 5 is 93. The preimage of 93 is 5. What's the output if the input's 6? Here's your input of 6, output 113. That's why we use the arrow to give a sense of direction, first and second. List the domain, that's all the inputs. So that's 1, 2, 3, 4, 5, 6, and 7. The range is all the outputs. So that's 13, 33, 53, 73, 93, 113, and 133. All right, let's see you find these 6 evaluate eaches. Okay, so f of 9 would be 3 times 9 minus 4, which is 23. F of negative 3 would be 3 times negative 3 minus 4, which is negative 13. F of 11 is 3 times 11 minus 4, which is 29. Now, for G, it's best looked at as 2 times the input squared plus whatever the input was. So it's 2 times 4 squared. It should say plus 4. Don't know why it says plus 3. It should be 36. For negative 10, I'm going to get 2 times negative 10 squared minus 10, which is 190. And G of negative 2 is 2. This one I did negative 5. I don't know why I did negative 2. The correct answer for this would be 6 would be the correct answer when you do a negative 2 there. Okay. Relations and functions. Functions are special kinds of relations. The big thing is, we talked about it before, every input, that's what we have on the left here, can only have one line coming off of it. And then if it's not a function, there are 2 lines coming off of one, like with the 4 here. Each input is going to have 2 outputs. That's not possible. Okay, so let's see you do this. Composition of functions, g of f of 2, f of g of 2, and so on and so forth. We will have you work on these. And then we will do one more card, and that'll be it for the first video. Go ahead. Okay, so we're going to do the first two only, then we'll go give you some more time for the last two, in case you had difficulty here. So remember, we read right to left, we read backwards. First, I got to find f of 2. F of 2 is 3 times 2, which is 6, plus 5, which is 11. Then it becomes g of that. So I give 11 to g, and g is x squared, so g of 11 is 121. Okay, for f of g of 2, now I do the innermost parentheses on out. First I do g of 2. G of 2 is 4, right? 2 squared is 4. Then I do f of 4, which is 3 times 4, 12, plus 5 is 17. We'll give you another little bit to try g of f of x and f of g of x, as if the input itself was exactly x. Okay, so first I got to find f of x. Well, that's pretty easy. It's 3x plus 5, right? Then I have to give 3x plus 5 to g, and g takes whatever you're given in squared. So I got to do 3x plus 5 times 3x plus 5, doing double distribute. I get 9x squared plus 30x plus 25. Now the next one says f of g of x. So first I give the x to g, and that gives me x squared. Then x squared has to become the input for f, and I get 3 times x squared plus 5, which is 3x squared plus 5. Okay. All right, relations and functions. So the first one is a function because 1, 2, 3, 4. There's nothing here giving 2 outputs. The next one's not a function because 3 has 2 different outputs, -3 and 17. Take a look at the next two, determine which is a function and which is not a function. Well, the first one is a function because nothing repeats in the domain. 1, 2, 3, 4. Everything has an image. I don't care that they're both 10. It doesn't make a difference to me. I just care that 3 has an image and only one image, and 4 has an image and only one image. On the other hand, the next one's not a function. And it's not a function because 1 goes to 8, good, 2 goes to 9, and 2 also goes to -9. I don't think so. Not a function. Okay, so at this point, I would ordinarily go into a second video, but you know what? I've only got 2 slides left here before the happy recap, so I'm just going to keep right on going, and we're only going to have 1 video for this lesson. Radical equations, isolate and square. So that's what we want to do here. Whenever we have a radical equation, we want to isolate and square. So in these, all 4 of these, the radical's already isolated. So it's isolated already, so I just square both sides. If I square the square root of x, I get x, and if I square the 9, I get 81. That makes sense, right? Because if I plug the 81 back in for x, the square root of 81 is 9. Okay? You try the next one. Go ahead. Okay, it's already isolated, so square both sides. I get square root of 2x minus 1 squared. Well, those are inverse operations to square and to square root. So on the left, I just get 2x minus 1. And on the right, 7 squared is 49. Then I just solve the equation that results. Adding 1, dividing by 2, and I get x is 25. And we could do a quick check on this, right? 2 times 25 is 50, minus 1 is 49, and the square root of 49 is 7. Looking good. Okay, try the next one. Go ahead. Okay. Okay, so the radical is isolated, square both sides. I switched which side is which because it's more normal this way. The square root of 3x plus 3 squared is 3x plus 3 because they undo each other. They're inverses, the square root and the squaring. And 3 squared is 9. Subtracting 3. Dividing by 3, x is 2. Last one's a little more challenging. Go ahead. Okay. Now, squaring both sides, I get, well, I should say squaring both sides, I get x squared equals 2x plus 8. It's a quadratic now. Get it all on one side. Factor. X minus 4 equals 0, or x plus 2 is 0. And on the left, I get x is 4, and on the right, I get x equals negative 2. But we're not done. See, negative 2 can never be an answer on this, and we call it an extraneous root. The reason that it cannot be an answer to this is because the square root of something is never the negative. It always works out to be the positive. So what we have here is negative 2 is not an answer. It looks like it could be, but if we check it, 2 times negative 2 is negative 4 plus 8 is 4, and the square root of 4 is 2, not negative 2. Now, yes, negative 2 times negative 2 is 4, but for convention purposes, unless it says negative square root, then we always assume the answer is positive. Okay, so remember, it's isolate the radical and then square both sides. So let me take you through number 1. With number 1, what I want to do is isolate the radical, so I do that by subtracting 3, and then I square both sides, and I get x is equal to 16, right? Because the square root of x squared is x, and 4 squared is 16. Okay, try numbers 2 and 3. Go ahead. Okay, so for number 2, square both sides. I don't need to isolate it. X squared of x plus 10 squared is x plus 10. 2 squared is 4. Subtract 10 from both sides. X is negative 6. Let's do a check. Maybe it's an extraneous root. Negative 6 plus 10 is 4. The square root of 4 is 2. That works. Number 3, first you have to isolate. Minus the 7, I get 2 equals the square root of x. And then I square both sides, and I get x is equal to 4. Okay? Try numbers 4 and 5. Go ahead. Okay. All right, so number 4. Well, I want to isolate that radical first, and I subtract the x squared. I forgot the little squared here. I get 3 radical x is 15. Then I divide by 3, and then I get radical x is 5. Square both sides, x equals 25. And if I check it, 3 times the square root of 25 is going to equal 3 times 5, which is 15, plus 5 squared is 25. So that would be 40, and then 15 plus 5 squared, which is 25, is also 40. So it works in both cases. Number 5, I have to subtract the 1 because I have to isolate it. Square both sides, x plus 5 is 4. Subtracting the 5, I get x is negative 1. And that does do a quick check. Okay, try 6 and 7. Okay, so now what we have here is, for number 6, I have to isolate the radical, which means I have to subtract the 7 and divide by the 2. When I do that, and then I square both sides, I get x is equal to 1. But wait a minute, that doesn't check. So 1 is an extraneous root. Now try to check it. 2 times the square root of 1, square root of 1 is 1, so 2 times 1 is 2, plus 7, that doesn't equal 5. So therefore, number 6 does not have an answer. The answer would be the empty set. And number 7, already equal to radical, so just square both sides, and I get 5x minus 2 is x plus 6, and you know how to solve that. Subtract the x's, add the 2, and I get 4x is 8, dividing by 4, x is 2. Quick check. Yeah, that's going to work. I get square root of 8 equals square root of 8. Okay, time for the happy recap. First step. What's composition of functions like? Describe it. Well, you're going to plug into one function machine, get its answer, and then take that answer and plug it into a second function machine. What's the difference between a relation and a function? Remember, in a function, every domain element has one and only one range element, or one image. And number 3, what important matters do you need to remember when solving radical equations? Isolate and square. All right, we are done with the only video for lesson 18.